Welcome to this lesson on working with ratios. Today we're going to talk about how to identify the four different parts of a given ratio, how to identify corresponding parts of information in ratio problems, and then how to use those ratios to solve problems. So you guys remember that time where we were sitting in class and you said, "Katie, you just haven't challenged me enough. I really need something more difficult." Well, here we go. Don't worry, it's going to be difficult. However, if you take your time, you identify your pieces, and you put things in their spots, you will be fine. You will struggle and you will have incorrect answers from time to time because we all make mistakes. However, you will find success with this if you keep at it and if you keep trying. So to start off, we have a riveting problem here where we're talking about the county superintendent of highways who is interested in the number of different types of vehicles that regularly travel within his county. I'd say get a different job. But this guy really likes it, so let's see what happens. So in the month of August, a total of 192 registrations were purchased for passenger cars and pickup trucks at the local Department of Motor Vehicles, which we call the DMV. And it reported that in the month of August, for every 5 passenger cars that were registered, there were 7 pickup trucks registered. We want to know how many of each type of vehicle were registered in the county in the month of August. First things first, we have to pull apart this problem. So we're going to go over again, even if it is a review and we've done this before. We need to go through and we actually need to highlight our question. So in this case, the question is, how many of each type of vehicle were registered in the county in the month of August? Now I want to know how many of each type. So I'm going to underline that because that tells me that I'm going to have multiple answers. So I can't just have one answer because it says each type. And because I know that there were pickup trucks and passenger cars, I know that there were 2 types. So I should have 2 answers. Running out of space here, started too far off to the side. So 2 types, so I should have 2 answers. All right, so now I also need to go through and I'm going to box important numbers. So this beginning part, it's really all just kind of fluff. It's really not that important. But I do want to note that there were 192 registrations, and that just says registrations. It doesn't say car, it doesn't say truck, it just says registrations. So that tells me that it's all registrations. Okay, then the next piece is that for every tells us that it's a ratio. 5 passenger cars, there were 7 pickup trucks. So if I come down here and I make a tape diagram of my information, I have my boxes drawn already. I know that this would be cars, and this is trucks. And I know that for every 5 cars, there are 7 trucks. So in this case, if I look at my ratio, it's 5 to 7. So let's find these 4 pieces of information. In this case, we're talking about cars and trucks. So one piece of information will be cars. And I know that in my ratio, in the simplified ratio, there's 5. Then there's trucks. And in my simplified ratio, there are 7. If I take these 2 things together and combine them, it's going to give me a total. In this case, the total of vehicles. Now the total is just that, a total. In this case, the label of it is vehicles because that's what we're working with. Your label will always be different based on the problem that you're working with. But a total is a total, so I know that altogether there were 12 registrations. Now remember, this is my simplified ratio because we're not going to sit on the highway and count the number of cars and then count the number of trucks. I really would hope that you had something better to do with your day. But who knows, you might really like cars and trucks. And then I also know that I can find the difference between the 2. So I know that the difference between 7 and 5 is 2. And I'm going to call that the more. And we'll talk about that a little bit later. But let's just look at it and say, okay, well, I know that there are 2 more trucks than there are cars. That's why we call it the more. When you look at your word problems, you're going to see the word more and not the word difference. So that's why I use it instead of the word difference. And you're always saying, okay, well, there's more of your larger number, which in this case is trucks, which is 7, than your smaller number, which is 5, that represents cars. Now, where does this 192 come in? Well, since that's the actual, so remember, this is simplified. And then we have actual information. And in this case, we have the actual total, which is 192. So we know that altogether, this gives us 12. But I want to know altogether, if this gives me 192, if I could write a 9. So if this gives me 192, how much does each of these have to represent? And then how many cars does that give me, and how many trucks does that give me? So again, don't look at these as boxes. Look at these as cars and trucks. And this is one car and this is one truck. So what we're trying to figure out is if there's 192 actual total, how many does every one car or one vehicle represent? So one vehicle represents some number of actual vehicles on the highway. Okay, so there's a lot of different ways that we can look at this, and first I'm going to start off with saying, okay, well, if this is 12, so all these boxes here is 12, I can take my actual total, so I have 192, and I'm going to divide that by 12, because I have 12 objects that can represent, so I have 12 total objects to represent the 192 total objects. If I do that, when I divide, okay, so 12 goes into 19 one time, and 9 minus 2 is 7. That bring down the 2 gives us 72, and 12 goes into 72 6 times. So in this case, every one vehicle represents 16 actual vehicles. So this is 16, and this is 16, and this is 16, blah, 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 blah. Okay, so, and if we want to double check our work, we always can with a calculator. So we can look and say, okay, when I take that actual total and divide it by my simplified total for my ratio, it gives me 16. And that tells me that every one vehicle represents 16 actual vehicles. So what that means is I can take this then and say, okay, well, since I have 5 vehicles in the ratio, 5 cars in the ratio, and each one of those cars represents 16 cars, I can take 5 times 16, and I can find out, so 5 times 16 is, 5 times 6 is 30, 5 times 10 is 50, 50 plus 30 is 80. So I know that there were 80 cars. And since each of these represents 16, and there were 7 of them, I can take 16 times 7. So I can write that out if I need to. It's 42, carry the 4. That's 1 times 7 is 7, plus 4 is 11. So I know that there were 112 trucks. Right? I know it can be a little confusing, and I know I have a lot written out here. I apologize for that. But what you have to understand is that we're saying that the 192 and the 12 are equivalent. So since they're equivalent, I should be able to use equivalent ratios to solve. So this is how we can do this in solving without looking at the ratio. So if you're understanding what's going on here, great. However, it can get a little bit trickier and a little bit harder. So what we are going to do is I'm going to duplicate this page. And then now that I've duplicated the page, what I'm actually going to go through and do is I'm going to clear the information that's on here, and we're going to start over by doing it with a ratio. All right, and when I do it with a ratio, I want to keep all this information. Okay, so bear with me here. This is going to be a lot of erasing. I'm going to keep everything. There we go. About my ratio. Again, here I need to know that this is my simplified information for my simplified ratio, and then my actual information is that I have a total of 192. All right, so if I set this up, I know that I have my actual total, and I'm looking for the actual number of trucks and the actual number of cars. Let's just start with cars. It doesn't matter, but that's what we're going to start with. And if I'm going to set that up in a ratio, my corresponding pieces, so it goes across from this piece, has to represent the same thing. So if this is the actual total, then here I need my simplified total. And if this is my actual number of cars, here I need my simplified number of cars. So in doing that, I know my actual total is 192 over, I don't know how many actual cars there are. I do know that with my simplified ratio, I have a total of 12 cars, and in that total of 12 cars, or 12 vehicles, I have 5 cars. Now, to figure out how I went from 192 to 12, I would do 192 divided by 12, which is exactly what we did before, and I would get 16. So again, and this is important because you are going to have to be able to do this, you have to be able to tell me every one vehicle in the ratio represents 16 actual vehicles on the highway. Since I know that 16 is what I multiplied by, I know that golden rule is, and I'm sorry, I multiplied 12 by 16. I divided to figure it out, but I have to multiply by 16 to figure out how to go from 5 to x. So I can do 5 times 16, which is 80. So I know that since x is our actual number of cars, I know that there are 80 cars. Now I can do one or two things. I can take my total, which is 192, and I can subtract, let me get out of this. I can do 192 and I can subtract 80, and that should tell me the number of trucks that are left. Or the number of vehicles that are left, which would have to be the number of trucks. Or I can set up another proportion or another set of equivalent ratios to solve. All right, so I know this is confusing. So what I am going to ask is I'm going to ask that on this next one, you read and you highlight the question, box your important numbers, and then come back to check to make sure that you did that piece correctly. Then I want you to pause again, and you're going to find your 4 pieces of information. All right, so here's the next problem. Please pause and highlight the question and box your important numbers, and then when you come back, we'll check to see that you did it correctly. All right, so we want to know how many did each boy sell. In this case, it's important to know that Nope, we don't care that they were raising money for football uniforms. We do care that they sold 5 water bottles and that that's Sammy's, and that for every 3 water bottles, or I'm sorry, for Sammy sold 5 for every 3 that David sold. And together they sold 160. Now what I want you to do is I want you to find your 4 pieces, so your simplified ratio, find those 4 pieces of information, and then I want you to find what your actual piece is that you know, and then come back and check your work. All right, so in this case, since I ran out of so much space last time, I'm actually going to type it out. So my 4 pieces of information. So in this case, the first is Sammy sold 5. And when Sammy sells 5, David sold 3. Total, that would mean they sold 8. And the more, so Sammy always sells 2 more than David. Okay, and again, this is my simplified information. My actual information is this 160. So together they sold 160. Since it's together, I know 160 is my actual total. Okay, so if I draw my tape diagram, which we need to be able to do, it's going to be Sammy and David. And then we have, so Sammy 1, 2, 3, 4. And that last one looks really huge, so I'm just going to adjust that. Luckily for us, drawing is not being graded here, so don't worry if yours don't look that great. And then here we have 1, 2, and then I'm going to make it smaller because we know that his is only 3. Okay, so what we're trying to say is, so right now we know that all together this gives us 8. But we want to know if all of this together gives us 160, what is each of these worth? So I can do it this way. I can say 160 divided by, well, there's 8 boxes, and that's going to give me 20. So every 1 water bottle that each of the boys sells represents 20 bottles. Actually, so I should say every 1 water bottle in the ratio represents 20 bottles sold. So every 1 bottle in the ratio represents 20 bottles sold. And now I can sit here and say, okay, well, if each of these represents 20, I can just do 20 times 5, which is 100. And I can do 20 times 3, which is 60. And since this is Sammy and this is David, I know that Sammy sold 100 and David sold 60. Let's set it up as a proportion. I want you to pause and set up your proportion and then come back to check and see how you did. All right, so I have my actual total, so that's what I'm going to work with, and I'm just going to work with Sammy since he's listed first. If you worked with David, that's fine. Just make sure you put the correct numbers in. So the actual total is going to be set up across from the simplified total, and the actual amount that Sammy sold is going to be set across from the simplified amount that Sammy sold. So let's replace our numbers. So in this case, I know that the actual total was 160. And then the actual amount that Sammy sold, we don't know. So we're going to use an X. We use a variable to represent. Now, if you use an S for Sammy, great. If you use something else, doesn't matter, just as long as you know what you're working with and you define your variable. So in this case, we have the simplified total, and I know that the simplified total is 8. And I put that over my simplified amount that Sammy sold, which is 5. So my simplified Sammy is 5. All right. So now, how did I go from 8 to 160? So I'm going to take 160 and I'm going to divide it by 8, which is exactly what we did here. And it's going to give me 20. So again, that tells me that every one bottle represents 20 bottles sold. So then now I know that to go from 5 to 16, or to X, I have to multiply by 20. And 5 times 20 is 100. And since X is representing the actual amount that Sammy sold, I know he actually sold 100. And then again, I can subtract. I can say, okay, well, since 160 were sold, 160 minus 100 gives me 60, so that is the amount that David sold. So then I know that Sammy sold 100 bottles. And I can even say when Sammy sold 100 bottles, David sold 60. All right, so we're going to stop here because I'm sure I've got your brains just reeling right now, and you are going to try these next 2 problems on your own. Big piece. Find your 4 pieces of information. Find your actual information. Set up your proportion. Draw your tape diagram. Take your time, go piece by piece. You're also going to be asked to type or to write your sentence. Every one blank represents blank actual pieces, right? So when you do your U-Try problems, you're going to have to make sure that you have that and make sure that you have it in your notes as well. So I'll write a quick little thing here. 4 pieces of information, actual information, and then your sentence. 1 blank represents blank actual. And then you also need to have your tape diagram. All right. As always, if you have any questions, please be sure to email me or write them down so we can go over them in class.